It's everybody's favorite time. Sig Figs. No, Mr. Batson, don't make me learn these Sig Figs. Okay, so full disclosure, when you get further and you do full-blown air propagation, you won't use Sig Figs pretty much as much. You'll just kind of look at what your measurement's giving you, you look at the standard deviation of it, and then you are stuck doing a lot of math. If you want to get stuck doing a lot of math, go check out the air propagation videos, because that's what you're going to need in college. If you're like, whoa, I just watched those videos, I have no idea what adding in quadrature is, I'm just going to stick with Sig Figs, then here we go. So Sig Figs are basically giving us an idea of what we actually know. For instance, let's imagine for a second, and I do this in air prop, let's say you have a door, right? And here's a doorknob. And I say, hey, this doorknob is 2.1 feet off the ground, and it is, the doorknob to the ceiling is 6.8314215 feet. And then I ask you the question, how tall is the door? Okay, so from the floor to the doorknob, it's 2.1. From the doorknob to the top of the door, it's 6.8514215 feet. So how tall is the door? Well, if you just took 2.1 and added it to the 6.8 whatever, you'd be like, oh, it's 8.9514215 feet. But that's not correct, because you don't know anything beyond the 2.1. Like, that 0.1 was a guess. Remember, that's an estimated digit. You don't know if this is even 2.1. It could be like 2.0. It could be 2.2. There could be numbers after these that you just don't have the precision to measure. So this 8.9 could be correct, but this down here could be totally different. And because we don't know those measurements, because we use two different rollers on these, we have to use Sig Figs. Okay? So that's the purpose of Sig Figs. It doesn't pop up a lot in our high school setting because we normally use the same rollers to measure everything. But in a real life scenario, you know, you might be measuring something with like a car odometer, which is measuring in miles, and then measure the last little bit with a roller or something, which is much, much more precise. So this kind of messes things up for us, and that's why we use Sig Figs. Okay, we just don't know some information. So let's talk about how to determine Sig Figs first, and then we'll talk about adding and subtracting them. We've got two rules for Sig Figs. Well, two and then part A, B. First, if it's a number 1 through 9, it matters. Okay, it is a significant number. Zeros are weird. Zeros are everybody's headache. Okay, zeros can be thought of in two ways. If you sandwich a zero, it has now become significant. For instance, if you have an Oreo cookie, the cream is significant. It is in the center. So if we look at this first one here, this 0 in between the 7 and the 4, that is significant. You sandwiched it between the 7 and the 4. It matters. Okay? The other way to make it significant is if it happens to come after the decimal point and after a non-zero digit, a 1 through 9, then it is also significant. Okay? So if it's a 0 at the end of a number, it matters. So let's take a look at some of these and get some ideas of the Sig Figs. Okay? If you want to practice, and I recommend doing this, pause the video, see if you can get what these Sig Figs are, and then I'll go through it. That was my pausing face for some reason. Okay, so here we go. The 7 matters, so that's 1. The 0 is sandwiched between the 4 and the 7, so it's 2. The 4 is a number, so it's 3. The 5 is a number, so that's 4 Sig Figs there. And let's take a look at these two zeros. Do they come after the decimal point? Yes. Do they come after a non-zero digit? They come after the 5. So boom, both of them are Sig Figs. So there's 6 Sig Figs in this first one. Here, let's take a look at this. For the 2.00, is the 2 significant? Yes, so that's 1. Is this 0 significant? Well, it comes after the decimal point and after a non-zero digit. So boom, it's significant. Is this 0 significant? It's after the decimal and after a non-zero digit, the 2. So boom, it is significant. Okay, so there's 3 there. Let's take a look at this one. The 3 is significant, so that's at least 1. Let's take a look at these zeros. Does this first 0 come after the decimal? No, so it doesn't matter. Does this 0 come after the decimal? Yes, so do all the other ones. Do they come after a non-zero digit? No. So they don't matter. There's only one sig fig there. Let's take a look at this here. How many sig figs do we have? This is 6.7 times 10 to the second. Ooh, this is a little weird. Well, the 6 and the 7 are good, so that's 2. Do these zeros come after a decimal? Yes. Do they come after a number? The 7? Yes. So both of them count. There's 4 there. Okay. If you also wanted to rewrite this, this would be 6700. And if you're doing it this way, and the reason why we like writing in scientific notation more than this, this you'd be like, well, there's only 2 in that. We'll talk about it. Actually, there's be a decimal there. Okay, so we'll talk about that in a second. For our last one here, we've got 4 and 3, which is good. Then dot or decimal point 00. Well, these zeros are sandwiched between the 2 3s, so they do matter. And the 0 is after the decimal and after a 3, so all of these matters. It's 1, 2, 3, 4, 5, 6. There's 6 there. Okay. For this 670.0, this would actually also have 4 decimals, kind of in a weird way. The 6 and 7 both count. Check, check. This 0, you might not think it's sandwiched, but this 0 at the end is after the decimal and after a non-zero digit, the 7. So that one matters, and now that they're both sig figs, this matters. We like writing it like this a little bit better because it's easier to count the sig figs like that. Okay, so that's how you count sig figs. You only need to count sig figs whenever you're multiplying and dividing. When you're adding and subtracting, you don't need to count sig figs at all. All you need to do is add just like you did in elementary school, okay? So you put things in their tens columns and the ones columns, and all the decimals are in their columns, and then you just add them up, okay? Just like you always did. So let's just zoom in here, make this a little bit easier for me to add. 6 and 3 is 9. Ooh, that is a really thick 9. 8 and 4 is 12, plus 1 is 13, so we'll put the 3 down and carry the 1. 6 and 1 is 7, 7 and 3 is 10, plus 2 is 12, so here's the 2, carry the 1, there's the decimal. 4 and 1 is 5, 6, 7, 7 and 3 is 10, so we'll put a 0 here, then carry a 1, and then there's the 30. So 30.239, okay? Then we pull out the buzz saw. We look at whatever number we have, what is the number that has the least precision on it? 3.21 ends its precision here. So we're going to buzz saw just like that. Boom. This means that whatever is after this is going to get cut out. We have sawed it off. The only thing we're going to have to do is look, do we have to round? That's a 9, so yeah, we're going to round there. So 30.24, and the rest of it got buzzed, sawed off. Okay? That's it. You just say, like, look, this is the least precise thing I have. Whoosh, buzz saw. And just do the rounding if you need it. Okay? That's it. That's all it is. Buzz saw. Buzz saw. I just chant that all day if we were in school. Okay? The multiplication is the pain in the butt one. You just can't take a buzz saw to it and call it a day. For the multiplication, what you need to do is you do your multiplication just like always. You know, 1 times 2 is 2, and 1 times 2 is 2, 1 times 3 is 3, and then we put the little 0 or the line there, and 2 times 2 is 4, and 4, and then 6, and we add them all up, and we go 2, and then we do 6, and this is 7, and this is 6, and then because, you know, decimals are a thing, this decimal went over 2, and this decimal went over 1, so when we put those together, we get 3, so 1, 2, 3, and our decimal sits here, 1, 2, 3, okay? But, how do we do this for sig figs? Well, what we need to do is we need to look at our actual numbers here, the 3.22 and the 2.1. 3.22 has 3 sig figs, because they're all numbers. 2.1 has 2 sig figs, both are numbers. We take the lesser sig fig amount, which is 2 in this case. That means our final answer, the 6.762, can only have 2 sig figs, starting from the largest quantity, the ones digit in this case, and then working down. So our answer would be 6.7, but don't forget to round, which makes our answer here 6.8. 2 sig figs with a rounding. Okay? That's it. There are some weird special cases here. If you're in geometry and you're doing something like circumference, circumference is equal to 2 pi r. The number 2 in this equation has infinite precision. You can't say like, oh, if you're taking the number 2 and you're multiplying it by pi, and you're multiplying it by r, which is like, I don't know, let's just say it's like 4.38. You can't say, oh, there's only one sig fig here for the number 2. We can only have one sig fig in the end. No, this number 2 is a mathematical definition. It actually represents 2.0000000 forever. It has infinity precision. It is not the sig fig limiter here. Pi, the irrational number, 3.14, blah, 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 goes on forever. It has infinite precision there, okay? This only has 3 sig figs. This is what's going to cause you to bump down to 3, okay? Furthermore, for what we're going to do this year, angles, you know, if you have something like this, like this angle is 32 degrees. In theory, this angle number would have sig figs to it, okay? We are going to assume that these angle values are exact, that they have infinite precision whenever we use them for trig functions, that's sine, cosine, tangent, and the inverse functions of those as well, okay, the arc functions. If you know what I'm talking about, great. If you're like, what the heck is sine, cosine, tangent, then when we get to it, you'll understand. The reason we do this is these are functions that we have to put these into, and things get weird when you put them into functions. You're best actually using an air propagation for this if you wanted to do that. But we, for what we are doing in class, are just going to assume that they are exact numbers with infinite precision when we use sine, cosine, and tangent. Okay? If you're confused about that, you want more information, hit me up or come talk to me in class. But with this, our sig figs idea is complete. It is finished. Or figness? I don't know. Whatever. Adios, everybody. Have a good one.